Our sun is the world's most abundant and cleanest source of energy. As students in the Earth and Environment Department of Florida International University, it is our duty to make solar energy on campus a reality. Solar cells convert sunlight into electricity through a process called the photovoltaic effect. A solar cell is made up of two silicone panels, an N-type layer and a P-type layer, which are sandwiched together. Front and back contacts are placed between the two layers. Finally, glass is installed on top to protect it from damage. Sunlight separates electrons from their atoms, which allows electrons to flow through to produce electricity. The cells collect sunlight and convert it into direct current. From there, an inverter converts the energy into appliance-friendly electricity called alternating current. There are three types of inverters: string inverters, also known as centralized inverters, microinverters, and power optimizers. String inverters are the most cost-effective compared to the others. The panels are arranged into groups connected by strings. Each string panel is connected to a single converter. This technology has been around for decades. The biggest downfall is that a string of panels will only be as effective as its weakest panel, so it's not recommended for shady areas. Microinverters tend to be more expensive, but it has its benefits. Microinverters are installed at each individual panel so it converts DC into AC right on your roof. A major benefit to this system is that one panel will not affect another, so you would want this system in shady areas. In addition, you can monitor the performance of each panel individually. Another benefit is that you can connect more panels as your energy needs increase. Power optimizers are the best of both worlds. Similar to microinverters, power optimizers are installed at each individual panel, but instead of converting DC into AC on the roof, it is carried down to a string inverter where the conversion to AC occurs. Similar to microinverters, you are still able to monitor the performance of each panel, but at a more affordable price. There are three different types of solar panel systems: off-grid, grid-tied, and hybrid systems. Off-grid systems can run independently from the grid. Solar panels generate DC power. It is fed into a charge controller, which is used to regulate the charge instead of relying on the utility company. From there, it is transferred and stored into a DC battery bank. The inverter is connected to the home, which converts DC into AC power. Grid-tied systems work parallel with the utility grid. The DC power from the panels is converted into AC power so it can be used to power appliances and electronics. Installation also requires special meters that sell back excess power to the utility company. If for some reason your system produces less power than you need, you will receive power directly from the utility company. Hybrid systems combine the best of both worlds. You have the convenience of being connected to the grid as well as selling excess electricity back to the grid. In addition, you'll have a battery backup in case of outages. So how can we bring solar panels to FIU? We are proposing an installation of a solar canopy on top of PG5. The solar array would provide shade to parked cars while producing renewable energy. For an all-year optimized position, the panel would face south at a 64-degree angle. The 108,000 square foot roof would house 2,700 solar panels and cost a total of $1.4 million. When you consider an average sun exposure of 5.5 hours and 300 watts per panel, that would produce 134,000 kilowatt hours per month. That's enough energy to power FIU Arena at 100%. FIU would pay for the solar canopy by charging students a solar energy fee of $2 per semester. That would generate an average income of $250,000 per year. In addition, there are different incentives depending on your state and eligible sector. Currently, according to DesireUSA.org, FIU can qualify for a loan program administered by the U.S. Department of Energy, not to mention the different grants that are available to universities. To start the project, FIU would take out a solar energy loan from the myriad of banks offering this service. Combined with the proposed solar energy fee, FIU would have the loan paid back in no time. There is no questioning the monetary savings and environmental benefits of solar power. At FIU, the students are responsible for influencing change towards a better and more sustainable future. Thank you for watching.